Hi, this is Sandy Sims with STS Digital and the Sequarallel. This video is to demonstrate a few alternate functions the Sequarallel can be used for. One that may have crossed your mind already is to generate several clocks. Some divided, maybe some multiplied, or perhaps a short burst of clocks. I have pre-configured 3 tracks trackers, each with 4 lanes, making 12 possible outputs. This conveniently matches the jacks vertically. We will be using drums mode, as the default drum layout on the jack starts with note 36, or C3. Tracks 1's lanes are C3, C-sharp 3, D, and E-flat notes. The clock rate of this tracks 1 is times 2, so we'll do 2 steps on every clock. This is the default, as 1/8 measure clocks are popular. The next, tracks 2, has some clock bursts for the demonstration. These are notes E3, F3, F-sharp 3, and G3. It doesn't really matter which lane you're in, but looks more organized, plus allows for easier bulk editing, like adding note effects to all effects numbers. This is also clock times 2. The notes here for the final vertical row of jacks is A-flat 3, A3, B-flat 3, and B3. Tracks 3 uses note effects to get faster clocks, even though the clock multiplier goes up to times 8. The first lane, the A-flat 3s, is using note effects 1, which has 8 echoes. It should be 7 because the original counts as 1, and 1 plus 7 is 8, right? So these notes will only be 6 ticks apart, which is 1/4 of a step, steps being 24 ticks. That's 2 times 4 equals 8 times the clock speed. What I didn't show here is there's a +3 curve on the echo, so this burst's rate slows a bit. It's a cool feature, as you'll hear once we hit play. So lane 2's notes, A3s, use note effects 2, which has an echo of 12 ticks, which will do 4 times the clock echoing. You can get the clock multiplication factor with the formula 24 divided by ticks setting. Lane 3 with B-flat 3 and note FX3 is at 6 ticks, so we'll fit 8 notes per clock, or 4 per step. They're every second step, so will sound continuous. Lastly, lane 4 in tracks 3 is using note effects 4, which is a tight 3 ticks per echo, thus fitting 8 notes into a single step, or 16 times the clock. All of these tracks trackers are on MIDI channel 10. They have to be in order for the drums CV mode to recognize them. So CV mode must be changed to drums. This setting remains for all song projects, assuming that that's the patch you're using at this particular time. Under the drums quick box, make sure your source is tracks and that the drum set for this layout matched the ones we have set up in tracks. They can be edited here or in the main screen. In the main screen, just scroll up to the top, then continue into the drum boxes. The name of the drum comes up when it's changed, although that's not important for this application. The layout on the screen matches the top 12 jacks, but the yellow LEDs are shared by the 8 right-hand jacks. So let's give this a go. I'll patch in a VCO with an LFO on its pitch CV. Note 36. Note 37. Note 40, which is just a slow burst of 4. Let's patch in a second VCO. That's the first lane of track 3, note 44, the one with the curve. Note 45 is just 4 times the clock. Here's the original clock. The clock out is sending because we're self-clocked, so the Sequarallel is truly a BPM clock source. Note 46 on its jack is times 8. The cool thing is one tracks can have a swing while the other not, so an 8th measure clock can swing while an ARP clock does not. Anyway, that's how to turn the Sequarallel into a multiple clock source. Before we continue, I want to mention gate delay because it's not in any other video thus far. For most applications, having the CV and gate change almost exactly at the same time is okay, like for a VCO or a filter. But if driving a digital module, that module may need some settling time on the CV line before the gate is applied. Very simple sample players can have this issue, while others can have a built-in delay, so it's not a problem. In any case, if you require 2 or 3 millisecond delay to let the CV line settle, there is an adjustment in the settings quick box. It's right at the bottom of the list. As you can see on the scope, there's more of a delay. This setting can go up to 9 milliseconds. Anything higher than that, you might as well be running a DAW in the 90s, right? The default, though, is 1 millisecond. The next alternate function is using a recorded note sequence from envelope's CV draw to sequence actual notes to a VCO. Tracks 1 notes are patched into CC5 jack, which is set to be an input as envelope CV draw mode uses CC5 to get the voltage to record into envelope memory at varying rates. CC1 output is then selected by the envelope settings as the direct destination, which is patched over to the VCO's pitch CV input. And tracks 2 send some gates to the VCO so we can hear the results. Success with this patch greatly depends on whether or not you have tuned a VCO and that tuning is selected, as well as on the tune offset note. Selecting an unconfigured VCO tuning with note 36 as an offset will yield similar results to this video. So here's what we'll be recording into the envelope. Tracks 1. Tracks 2 will be the source of the gate for the VCO as shown in the diagram. Well, after we play with Tracks 1's gate first. You can see the green LEDs flashing. So we're going to record the 1 volt per octave CV output of Tracks 1 into the envelope via CC5. CV draw is the envelope creation method for this. Hitting record will record and re-record the CC5 input until pressed again, at which point the last full screen recorded is transferred into the envelope. I'll patch in the VCO's gate to Tracks 1's gate output so we can hear what's going on. You can see by the waveform that the CV has glide applied to it. That setting is in CV mode. Because the envelope itself is being triggered by the notes of Tracks 2, and the rate of record is different from the rate of play, some interesting results can be heard. Reloading a new sequence completely changes the cadence and order. Turning the knob one way or another while recording will speed up or slow down the envelope sample rate, so less or more notes can fit into the recording window. In envelope 1 settings, changing the play rate is very obvious. I'll leave it at 3 clocks. Now I'll patch the VCO's gate over to tracks 2, which is only 2 notes over the whole sequence. Need to add some release time to the VCO so we can hear more of the envelope. Shortening the envelope length fits more of the notes recorded into the time span before the next gate. Changing the trigger source to free running will cycle the envelope, thus the note CV sequence, through the gates at a different rate to the tempo. Because the sample size won't ever align to the exact clock rate, it will always move one way or the other. Back to record a new window. You may notice the tones aren't perfectly in tune. They never will be, as there's a variation from input offset, CV note offset, and also just voltage errors, but it can be close enough with some tuning here and there. I think it's a pretty cool patch. Another alternate function that's not built in is converting notes to chords. This method uses remote notes to arm different parts of a track's tracker sequence, with the loop size set to 1 or 2 steps. The song project note remotes must be set up to your liking by turning on Remote Learn, then setting the bottom parameter in tracks and hitting the note that will point the sequence there. Here's the list of remote notes set to do this, starting at 84. The lowest part of the sequence is empty, providing a pause. This can be set to a note, or, as I have done here, set to 1 and enter. Then select the first step, which is 3, and hit the note on the keyboard to learn it in. This way, holding the lowest note, which is C here, will return the sequence to step 1 on release, enacting basically a pause. The track sequence size is set to 1 step. I space them apart more for the visual. Remote is on channel 16. I am using track remote offset on keyboard note 36, so I'll hit play from there. Timing is important though with this, as naturally everything is quantized to the beat. You can hear the high notes as I play because the MIDI is split to a different GM synth. Normally with remote you won't hear these notes, but as I align them to call the chord for which it is the root of, I thought it might be a good idea to make it audible. Notes held for more than 3/4 of a second will revert to the previous setting, which for these is always the bottom step before. During the learning phase, if you were to go to step 1 and enter that, then adjust to the chord step and hit the note to program it, any note held would return to step 1. This could also be arranged in a way that after held the chord returned to is always consonant. or dissonant, if that's the intention. By the way, there's the same note effects on all notes. This has an octaval randomization using microarp starts, and also a probability setting which varies the chords on each pass, as some notes don't play, which is why it sounds so dynamic. I hope you've enjoyed the video on alternate uses for the Sequarallel, and that it has maybe sparked some ideas for you too. I'm Sandy Sims. Keep on patchin'!